There's this profound idea. Imagine delegating a complex software project, going to sleep,
And just waking up the next day.
and waking up to find the entire thing is finished. Not just finished, but debugged and uh, committed to version control.
Yeah.
I mean, that sounds less like a dream and more like the actual potential of these fully automated coding agents.
It really is a profound shift, and I think that's why this Ralph Wiggum Agent concept from developer Ryan Carson has struck such a nerve. It completely changes how we interact with AI for coding.
How so?
We stop, babysitting the AI with constant little prompts and start actually delegating big structured jobs to it.
Okay, let's unpack this, because
Yeah.
the difference between this agent and just, pasting a huge request into a language model is immense. Welcome to the deep dive.
Today, we are really immersing ourselves in the mechanics of what makes this system work.
Yeah, our mission today is to get into the engineering elegance of it all. We're going to look at the genius of this task-specific loop and why that constant memory reset is the secret sauce for reliable code.
Then we'll spend some serious time on the planning part, the product requirements docs, or PRDs, and the acceptance criteria, because that's critical.
And finally, we'll walk through the actual practical workflow. We need to see how this thing runs locally, how it manages version control, and what all this means for founders and for developers who are just tired of writing boilerplate.
I think everyone has felt the frustration of trying to use a traditional chat-based AI for a big project. It's a universal pain point.
Oh, absolutely. I've been there so many times.
You start a chat, you ask it to, I don't know, build a comprehensive inventory management system, and the first response is great.
It's excellent. But then you start adding detail, like, okay, now integrate oath.
Now make sure the filtering works. And suddenly the AI seems to have completely forgotten what you asked for in step one.
You've typed so much that the AI is just drowning in information it can't process anymore.
Exactly. That is the core constraint, the context window.
So the context window, in plain English,
Sure.
What is that?
It's just the limited amount of short-term info, like the conversation history and code, that the AI can hold in its working memory at one time. When that fills up, it loses focus. The code just breaks.
So the solution here is simple, but it's kind of brilliant. You treat the AI like a new, very capable, but very junior developer.
Yes. You never ask them to build the entire app.
No.
You break it down into the smallest possible jobs. Build the login forms HTML, or implement the database migration for the user table.
And that's the engine of this Ralph Wiggum loop. It's reliable because it has this tight, specific cycle for every single task.
Right. Let's walk through that cycle again, because this is what really makes the difference.
Okay.
It picks task A, it writes the code for task A, it runs tests on that code, it saves the work with version control, and then, and this is the key, it deliberately purges the memory of task A's details.
So it moves to task B with a completely fresh, focused mind.
A fresh context window.
That reset is fascinating. So if the context window normally limits how much you can do, how does this task-based approach get around that fundamental constraint?
By resetting its memory after each save, the agent always gives 100% focus to the current small objective, but, the loop is only as good as the instructions it gets.
Right.
Automated coding absolutely requires a solid foundation, and that starts with the PRD, the product requirements document.
And this isn't just a suggestion. It's like a detailed contract that outlines exactly what needs to be built.
And how you'll measure success. This is where that old saying, garbage in, garbage out, becomes a real threat to your project. Vague instructions. You're guaranteed to get messy, useless code.
And then you, the human, have to spend hours cleaning it all up. The agent will just guess to fill in the gaps.
And the guesses are almost never what you want. I mean, compare a vague instruction like, make a user profile page. What does that even mean?
Right. What color is it? What date is on it? It could build a page that just shows the user's favorite cereal.
Exactly. Whereas a good instruction says, create a page showing name, email, and photo, include an edit button, ensure the save button updates the user's table in the database.
That specificity isn't just helpful, it's mandatory.
And here's a clever trick from the source material. You can even use a second AI to help you write that detailed PRD in the first place.
So you're using AI to create the clarity that the main coding AI needs.
You got.
So beyond just listing steps, what kind of user information does a good plan need to include for the agent?
The plan must clearly define who uses the feature, what every single button does, and how errors are handled.
So we have the high-level plan, the PRD, but the agent can't execute a document. You have to translate that vision into something the computer can follow.
And that's where we bring in JSON.
JavaScript object notation.
Right. It acts as the machine-readable contract for the project. It's basically the computer's structured executable to-do list.
And inside that JSON, we break features down into what are called user stories. These are just small, bite-sized actions.
Things like, as a user, I can see the login form. Or, as a user, I can type my password into the password field. Really small.
And this leads us to what feels like the real magic of the system, the acceptance criteria.
This is it. These are the specific binary rules that tell the agent if the job is truly functionally done.
So if I say, make the button work, that's subjective. An agent has no idea what work means.
Exactly. Human language fails the automated test. You need a pass-fail condition. So instead of make it work, you provide a technical definition.
Like what?
Acceptance criteria. When the submit button is clicked, it must send a POST request to the Apple Agent endpoint and get a 200 OK status back. That 200 OK is the computer's way of saying success.
And I think the elegance is how the JSON structure forces you to do this. You have your tasks array, the human readable story, a status that starts as pending.
And then a list of these incredibly precise technical acceptance criteria that allow for automated testing.
Whoa. I mean, just imagine scaling that precise, verifiable process, that constant automated pass-fail check across a million lines of code.
That level of structure is what separates this from just being a hobbyist script. It's about production-level reliability.
So what's the main outcome of setting such clear acceptance criteria?
Clear criteria tell the agent exactly what tests to run to automatically confirm that the code is correct.
Okay, now let's get into the operational flow. We have the plan, the structured JSON list. How does this script actually run? Because it's not in a chat window.
No, that's a huge point. It's a local process. You run a Python script, let's call it Ralph.py from your local terminal right inside your project folder in VS Code or whatever you use.
And that script reads your local tasks.json file, finds the next pending task, and just starts the loop.
And that local execution is so critical. The script might send the request for the code itself to a remote API, like Claude or GPT-5.
But the real work happens on your machine.
Precisely. The agent reads your existing local code files for context, it silently writes new files or modifies old ones right there, and then it runs the verification tests on your local machine.
So it always knows the current state of the project.
Exactly. And then we hit the autosave. This is more than just saving a file. This is integrated version control.
So once the code passes all the acceptance criteria,
It automatically runs a git commit command.
that's the genius of it. It packages the work into a verifiable historical record.
Yeah.
So if the agent breaks something later on, say in task 7, you can just go back in time to the commit from task 6.
It makes the whole process non-destructive. If a run fails completely, your last completed task is still safe.
Boy.
And only after that successful commit does the loop reset happen. The agent updates the JSON to complete it, and then it deliberately wipes its short-term memory of that job.
Back to a blank slate, ready for the next task.
And it just keeps going until the list is done.
So why is running the tests and saving the files locally with Git so critical for this method's reliability?
Local execution lets the agent modify existing files and save verifiable checkpointed versions using proper version control.
Okay, but if the agent is resetting its memory constantly, how does it maintain any consistency? How does it remember we decided to use Python, not Java, or a specific styling library?
That's where the two distinct memory files come in. This is how the architecture maintains the long view.
Okay.
We have long-term memory, which is stored in a file called agents.md. Think of this as the employee handbook.
So it's the rules that never ever change for the project.
Exactly. It defines the constraints. It says, use Python 3.10 in Django for the backend, or always add descriptive comments to every function, or we must use Tailwind CSS. The agent reads this entire handbook before starting every single new task.
You know, I have to admit, I still wrestle with prompt drift myself on complex tasks. So using a file like that, the agents.md, to just lock in the style and the rules, that sounds like a massive productivity and consistency buffer.
It is. It prevents the output from suddenly becoming inconsistent. But then there's the second file, short-term memory, the progress.txt file.
This is the sticky note on the desk.
Precisely. It's for immediate context. After finishing task 1, the agent writes a quick summary here, like, login button finished, confirmed database connection is set up. It reads this note before starting task 2.
So it doesn't have to redo work. It knows the database connection is already there.
It connects the adjacent pieces of the puzzle. Now, we do have to mention the cost. This whole process uses tokens through a paid API key. It's way cheaper than a human developer, but for a massive project, those token costs can add up.
So you have to budget for it.
Yeah.
If a developer tries to cut corners and skips setting up that long-term memory file, what's the immediate result they'll see?
The code would likely become inconsistent in terms of language, styling, and adherence to company standards. So when you look at the payoff, who really gets a superpower here? I think for founders and entrepreneurs, this lets you focus 100% on the business logic, the what, and the why.
And the agent just handles the heavy lifting of the how. You can iterate and test prototypes so much faster and cheaper without needing a big agency from day one. It's transformative for speed.
And for experienced developers, this system handles the grunt work. Writing form validations, setting up basic database tables, creating simple API endpoints.
All the boring stuff.
All the boring stuff. So the developer gets to focus on the hard, interesting problems like architecture or a novel algorithm. You write the specs, and Ralph builds it while you sleep.
But let's bring in a reality check here. This sounds amazing, but isn't writing a perfect set of acceptance criteria for a really complex feature sometimes harder than just coding it yourself? Where's that trade-off?
That's a legitimate tension. The upfront investment in planning is high, but the trade-off is predictability. Once the agent starts, it moves at machine speed. And you have to remember the central warning. Ralph is a junior developer.
Meaning you still have to review the code, it creates a great first draft, but human oversight, a security review, that's all still essential before production.
For sure. Though the future will likely address that. We're already seeing concepts for self-correcting agents.
How would that work?
They'll actively search documentation, figure out why their tests failed, and then fix their own bugs without a human needing to step in.
And what about the idea of collaborative agents, like a whole team of bots?
Yeah, one agent codes, another reviews it for security, a third handles the design. They could work together to build complex systems exponentially faster.
So if we tie this all together, the Ralph Wiggum method turns what's often a messy, complex negotiation with an AI
into a structured, manageable engineering workflow. It succeeds because it combines breaking work into tiny user stories, enforcing verification with acceptance criteria, and using that loop with clear long-term and short-term memory.
The setup requires that crucial upfront work, the detailed planning, the structured JSON, but the payoff is tremendous acceleration and reliability. I think the advice to start small is key. Automate building a simple website, maybe, to see how it changes the dynamic.
Yeah, and think about the cost savings, not just in money, but in the psychological cost. You get to focus your human energy only on creative problem solving.
So, a closing thought. What major problem could you finally afford to tackle if the most repetitive, time-consuming parts of the workflow were handled reliably while you just managed the master plan?